changes. This is all that is from last year to the VP of software in Gideon. Just my background. So my background is robotics automation. I obtained my master's and PhD here at the Faculty of Electrical Engineering and Computing with a group of Professor Kogan. So at Larix, I was working on control and modeling the one-man aerial vehicles. And shortly after my PhD, I actually went to Gideon, where I started working as navigation engineer and then moving up to these kind of leadership positions where I lead the complete software team working on software for autonomy of a single robot as well of controlling the fleet of robots. So I'm going to today briefly talk about Gideon, what Gideon is, how it's founded, etc. Then briefly about our product, so what do we do, and then also what's the kind of the technology behind that. I don't have much time, so it's going to be really a short overview. And then, as Professor already mentioned, I'm going to show again some details about the project where we collaborate with the fair and with some other industry partners, and describe the role, for example, of research groups from this university and how they helped us with this project. So let's get started. So Gideon is still a startup company from Croatia. So it was founded back in 2017 in Osijek. So from Matija Kopić, who had some previous experience with some startups. Soon after, the team from FAIR joined him and started building basically our autonomy or robotics platforms. So we are now roughly a team of 80 people, and we have really like a strong academia background with 10 PhDs working on different topics, from navigation, localization, visual perception, and AI. So we have offices now in Zagreb, in Osijek, in Croatia, but also we have some people in the States, mostly involved in sales, customer support, etc. And we also have manufacturing and testing roles both in Croatia and now also in the States, in Illinois, in Goodrich, in Illinois State, near Chicago. So what do we do? So Gideon is a product company. So meaning Gideon is developing product solutions for the market, and we are kind of approaching customers really face to face. So we started, as I said, we started back in 2017. We started, developing, let's say, a generic autonomy software for, let's say, any kind of platform, for any kind of robotic platform. But obviously throughout the year, we were trying to find our niche. We were trying to find the applications where we had some really, let's say, strong advantages over the competition, right? Where we could apply this software, this whole algorithm stack, where we could apply that, and where we could have some advantages over the competition. Throughout the year, we identified two areas or two niches in warehouse automation, where we saw that these areas were not automated, and there is a really huge potential for us to really automate. So the first one is autonomous tray loading and unloading application, and we call our solution Tray. And the second one is automated case picking solution, and we call this solution Casey. Just maybe briefly about the Tray. When I say solution, so Tray as a solution, as a product, actually it's comprised of multiple things. So obviously from the hardware chassis, so the chassis of the robot itself, autonomous software on the robot side that actually gives autonomy to this kind of a vehicle, and then all the way up to fleet management system that manages the fleet of robots, which is necessary, of course, to kind of satisfy customer needs, and then moving further up to some kind of application layer where we implement specific applications and specific integrations with customer IT systems that is needed for fully autonomous operation of this kind of a solution. So that's the Tray. So from the hardware chassis, autonomy on a single level, fleet level, and then application level that's needed for the end customer. For Casey, the story is quite similar. Again, the solution, the complete solution from the chassis to the robot software autonomy and then the application layer. What difference maybe between this product is Tray is more like a lone player, so the idea is that Tray operates fully on its own, fully autonomously, unless there is some exception and some help needed from the operator, right? So moving those pallets in and out of the trailer. While Casey, it's more like a team player, so we have both human operators, human pickers, and robots working together on order fulfillment, and not just generic order fulfillment, but really case picking. So So that's what we do. As I said, the complete solution comprises of all of this ware that I just described. I'm going to then briefly show a video of a tray in action in one of our US sites. So what you're going to see here is this manual forklift, autonomous forklift moving the pallets from the staging area in a typical warehouse environment into the trailer. What's challenging there is that there are a lot of variations, a lot of variabilities that can happen there. For example, you don't know exactly where the pallets are located. So you need to have a human level perception to understand where the pallets are. So that's one challenge. Another challenge is this environment can be really dynamic. There can be people moving there, there can be another forklift moving there. So you need to have a robust localization and navigation system that can account for that, right? And another challenge is, of course, the trailers that are placed there. There's a lot of variations in the position of the trailer, in the orientation of the trailer, and then again, perception is needed for this type of vehicle to really precisely understand where the trailer is and where the pallets should be placed or unloaded. So we're doing both loading and unloading. In this video, you see loading scenario. The question is, why this kind of application was not fully automated yet? Why? So what was missing, right? And the answer is really exceptional, almost human level visual perception. So that's the answer. And now I'm going to briefly talk about this kind of autonomy stack that really, deeply relies on human-like perception and AI. So Professor Petrovic gave a really nice introduction. So he mentioned some of the areas that his team is working on. And I have to say, we are also working on these areas. So all of these kind of components that he was mentioning, from perception, from SAM, from motion planning, that's something that really relies in every of our robots, or better to say, in every of our solutions.